So quiz number 20. We have a piece of bronze is a 10-1, copper to tin. So this is the copper is the 10, tin is the 1. How much bronze is produced if tin is combined with 32 pounds of copper? So we've got 10-1, copper to tin. 32 pounds is the copper. Cross, multiply, and divide. 3.2. Add them up. I won't confirm or deny that. Number 17. So I've got a part like this. We have dimensions marked here, 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 and here. This is one that stumps a lot of people until you do this. I'm going to make a blue line here and here. I'm going to slide those together to make a triangle. What's this dimension? What's this one? Now I'm going to make green, oops, that's not green. Green lines here and here. I'm going to slide them together to make a triangle. What's this dimension here? 1 inch. This one is X. How do you find X? These two dimensions go together. There you go. Those are similar triangles. That's one thing that you learn to notice the more you work with this. You can break similar triangles out of places where it doesn't look like there's any triangles at all. Yeah, you can just totally slice that out and get rid of it. Just slide this right on over. Because that dimension is still the same here as it is over here, so why not just push it over? Any others? 12. We have a drawing 1 inch to 2 feet. One inch, oops, equals 2 feet. That's a 1 to 24 ratio. 2 feet, 24 inches. How big would a part be drawn if the actual length was 4 foot 2 3/4 inches? Well, we have to change that all into inches. So 4 times 12 is 48. Plus 2 3/4 is 50 3/4. So then you'd find your drawn length. $14, okay? Obviously, I'm not drawing the scale here, but So we've got a radius equals 9 on the big pulley here. A radius equals 4. Radius equals 11.25. And we're asked to find the diameter of this pulley. We're given 352 RPM here and 2376 RPM here. So first we're going to find the RPM here because that's connected by a belt to this first pulley. That's the only pulley where we know both the size and the RPM. So we're going to do 18 times 352. Where did the 18 come from? Twice the radius. It's diameter times RPM. So that's going to equal 8 times whatever that RPM is here. So 18 times 352 divided by 8. 792. Now, would it have worked if we had just used the 9, radius of 9 and radius of 4? Yes, it would. But for consistency, I use the diameter. So what was that number? It just disappeared. 792 got there. So 792 RPM here. What's the 11.25 inch radius pulley going to be turning at? 792. So 11.25 times 2 is 22.5 times 792 equals this diameter times 2376. So 22.5 times 792 divided by 2376. It's 7.5. So this diameter here is 7.5 inches. If you had used the radius, you would get 3.75 there, but that's the radius. You'd have to double it. Okay, well, hopefully you've got a few problems right on the quiz. Any other last-second ones before we turn it in? Okay, before I collect it, anything else out of the packet that you want to go over? There's 38 in the packet. Number 38 is kind of a interesting little problem. There are some ways you could go about finding this. Now, I'm not going to draw out the outline of the part because that's not really necessary. Yep. That's a lot of these problems. This one especially, but yeah, a lot of these would be real easy if you intersection of two radii. Yep. So that radius from here to that center is 3.438 inches. This from center to center is 3.250 inches. And from this center to that center is 2.188 inches. They want to know the distance here, perpendicular. Well, to find that distance, there's some really tricky stuff we could do, but there's also a really simple process we can go through. There's a triangle right there, exactly. How would I find the perimeter of that triangle? Perfect. I just add all the sides. I get 8.876 inches is my perimeter. What would the semi-perimeter be? I just divide that by 2, right? You get 4.438. Which means the area is the square root of 4.438 times 4.438 minus 2.188 times 4.438 minus 3.250 times 4.438 minus 3.438. I'm going to call in the assistance of the calculator here. Not at this point in the morning.
Everybody else gets the right training.
So 3.444 is my area. Those are all in inches, so that'd be inches squared. Well, how does having the area of that whole triangle help me? Well, because the area of the triangle could also be found if I use this as the base, that's perpendicular to it. It would be, if I call this x, that area could also be found as 1/2 times 3.25 times x. So all I have to do is set that equal to this and solve for x. So I take my 3.444, I'm going to multiply by 2 or divide by 1/2. So I divided by 1/2 here. Get rid of the 1/2. And then I'm going to divide by 3.25. You get 2.1195, so 2.120 is x. Ready to tap out? Okay, let's grab your quizzes. Anytime you see something like this with a round object sitting in like a V or anything like that, it's going to come down to radius. And the fact that a radius is always going to be perpendicular. Yes, I am. That radius will always be perpendicular to a tangent. And now this one here is a 1 and 3 slope. This was a 1 and 2 slope. So we have from here to here is a certain height. That's really what we're trying to find, is that height, right? If we can find that height, the rest of it should fall into place. We know that this is going to be a 2-to-1 slope like that, and that this here is going to be a 3-to-1 slope. Just because it's perpendicular to these slopes, it's going to be the reciprocal. You flip the spots. Okay. So this one here, this one's obviously going to be lower than this one over here. So I'm going to find, I'll call this A and B here. Then I'm also going to find these triangles. So where this is C and D. We'll label this E and F here as well. So we're going to know some things about them before we're done here, hopefully. Okay then, so let's take a peek at, I'm going to label a couple more things here actually. I'm going to label this G and F just to refer to. What's a few extra variables among friends? Oops, you're right. So G and H. Good call. G and H. I'm going to start with this 1-to-3 ratio here. I'm going to make it into an actual full right triangle. I'm going to find the hypotenuse, which is just the square root of 1 squared plus 3 squared, or 3.1623. This here is also going to have that same hypotenuse of 3.1623. This is my radius of 1.25. This is my radius of 1.25. I can now find B and G over there because I know 3.1623 relates to 1.25 in the same way as 3 relates to B. So 1.25 times 3 divided by 3.1623. 1.1858 is B. I know that 3.1623 relates to 1.25 in the same way as 1 relates to G, which is going to make G 0.3953. For this one here, yep. Now I'm going to move over to this one, the 1-to-2. Find that hypotenuse. That's going to be the square root of 1 squared plus 2 squared, or 2.2361, which of course is the same as the hypotenuse here. So we're going to have 2.2361 relates to 1.25 in the same way as 2 relates to A. Yeah, 1.25 times 2 divided by 2.2361 gives us 1.1180. And then we'll set up the same proportion equals 1 over H. That equals 0.5590. So what we have a distance across here right now. That total distance is G plus H. 0.3953 plus 5590. Can't even write this morning. .9543, is that right? So 0.9543 is the total distance. We now know E and F. How do we know E and F? Well, because E has to have a 3 to F's 2. Not necessarily, do we? Got to be careful there. I know C and D is what I know. Possibly. I know that B plus C is equal to A plus D. So I know that 1.1858 plus C equals 1.1180 plus D. I know E plus F equals 0.9543. This whole distance across. I also know C over E equals 1 over 3. And that D over F equals 1 over 2. Remember those systems of equations we did at the end of last semester? Here's where they come to play with us. If I cross multiply here, I got E times 1 is just E. C times 3 is 3C. So E is equal to 3C. Cross multiply here, F times 1 is just F. D times 2 is 2D. So F is equal to 2D. So I just replaced E and F here with 3C and 2D. This equation up here, I'm going to rearrange. I am going to subtract C from both sides. And I'm going to subtract 1.1180 from both sides. So what I have here is D minus C. I'm going to write that as negative C plus D. That's just D minus C. Over here I have the difference of that, which is 0.0678. There is my system of equations. I'm going to multiply this bottom equation by 3. Why on earth would I multiply it by 3? Well, because this is a positive 3, this is a negative 1, so I'll turn this into a negative 3. Negative 3C plus 3D equals 0.0678 times 3, 0.2034. And of course, I still got the top equation, which I'm just going to rewrite. 3C plus 2D equals 0.9543. We add those equations. Negative 3C and positive 3C cancel out. 3D and 2D is 5D. And here we get 1.1577. We divide by 5. We got D equals 0.23154. C equals, I guess we'll have to come back to that. If we go back up to this, 3C plus 2 times D 0.23154 equals 0.9543. So I can now solve for C. I'm going to take the 0.9543, subtract 2 times D, then I'm going to divide by the 3 to get C. I'm just solving the equation. I'm just doing it all at once to save some time. So 16374, C 0.16374. So there's C and D. E equals 3C. Yep, so E is 0.49122. F equals 2D. So 0.46308. Well, now what do we know? We know. Oh, how does that help us? What's that? We know the distance. This distance h can either be b plus c or it can be a plus d, either one. Let's just do b plus c. B is 1.1858 and c is 0.16374. I'm going to remove the 4 because it goes past. I'm just going to round it off. 1.3495 is the distance from the bottom of the V to the center of the circle. What was that number again? 1.3495. The distance from the center of the circle to the top, of course, is just the radius, 1.25. Now what we need is the difference from the bottom of the V to the bottom of the figure. Well, what we have to do there is we have to use the dimensions on the side here. This is 2 inches, right? This here is 3 inches on a 1:3 ratio, which means this is 1 inch here, right? So from the bottom of the V down here, that's just 1 inch. So that total height is 1 inch plus 1.3495 plus 1.25. So it's 3.5995 inches that we get. What do you mean? A six variable system of equations is not fun? Yeah. Well, and realistically, when I've had to do things like this, I actually had, like the desk blotter size sheet of paper so that I can draw them out large. I mean, on this screen here, I really do not have room to draw it out large enough to really fill in all these little details, all this crap going on here. I would literally have that on my desk blotter drawn out this big so I can write in there all the different numbers. Yeah. Yes. And I actually have, I always had 3 or 4 different colors. I work in pen. For some reason, I cannot write in pencil. It just doesn't work for me. So I have, and actually you can see right here, I have 4 different colors of pens just sitting here. Okay, so you got the rest of the time to work on the test. You do get to take it home and bring it back tomorrow.